Hello everyone, in this video we are going to make the melting effect with the simulation nodes. With this setup you can melt or inflate any object with the self collision feature. So for this we will use the Blender 3.5 experimental build that has the simulation nodes. So let's get started. So I have set up this plane, and this is the geometry nodes. So first let's add two attributes to this mesh. And then I'll explain the melting concept. So temperature, and this one is the velocity. Okay, so let me enable this one. So suppose this is a mesh and these dots are the vertices of that mesh, and we have assigned the temperature and velocity to each of the vertices of the mesh. So then we will move these vertices based on their velocity, and the velocity is depend on their temperature. Means, so if the vertex has higher temperature, will move faster as compared to the vertex that has a low temperature. And on top of that we will add the damp factor to the velocity and temperature, so that will really sell this melting effect. And after that we will add the self collisions to this mechanism. So let's first make a group for this, because this build crash if we add the simulation nodes before making the group node. So now let's add the simulation nodes, simulation output node, then add the simulation input node. Now we're going to move these vertices based on the velocity. So let's add the set position node, and then add the named attribute node to get the velocity. So we have the velocity, but initial velocity is 0, so we have to add a force to get the velocity. So for that let me enable this concept. So if we have a force is equal to mass into acceleration. So in our case we are treating the mass of the vertices unity, so then acceleration become the force, and acceleration is derivative of the velocity. So if we multiplied acceleration to time with the time factor, this dt time step, we will get the velocity, and similarly we get the position from the velocity, because velocity is derivative of the position. So now let's first add the force, and then we will get the velocity and position. Let's duplicate this one. So now we have this vector, and this will be the direction of the force direction. Then we're going to normalize this direction, because we don't want our force direction affect the strength of the force. Then multiply this force by a factor, that is 9.8, which is acceleration due to gravity. Basically I want this force to behave like a gravitational force, and then we're going to multiply this with a factor that will be the strength of this force strength. Change this to a float. So now we have this force, and next we're going to multiply this with the time step to get the velocity. Time step, and this is 0.01. So now we have the velocity from the force. Let's add that to the existing velocity, and then store this velocity to the mesh. And next we're going to multiply this velocity, this is the resultant velocity, with the time step to get the position. So now let's goes outside this. Strength is 1, and also here change the default setting. Strength is 1, and by default the force direction is downward. So we have this. See, the plane is falling under the gravity. Let's also name this as melter, and also save this. So we have set up the velocity concept. Now let's affect this velocity based on the temperature. So let's duplicate this named attribute node, change this to a float, and this is temperature. Then we're going to add the temperature to the existing temperature, and this temperature can be any field, maybe based on the noise or your custom field. Okay, and we want the range of this temperature between 0 to 1, so we have to enable this clamp option. Let's duplicate this and output this as temperature, and then we're going to multiply this temperature by a factor that should be less than 1 for the damping. So this is temperature damp factor. Let's rename this. This is temperature and this is temperature damp factor, and temperature damp factor between 0 to 1. So we have temperature. Now let's also store this temperature, then we will multiply to the velocity. Change this to float and connect this to this and type here temperature. Okay, so now let's multiply this temperature to the velocity, to the existing velocity of the points, like this, and then we're going to also multiply it to this time step. So in this way we can multiplying the temperature to the velocity from the force as well as to the position. Let's multiply this to the time step, and next we can also add the damp factor to the velocity. Let's undo this and let's output this as a velocity damp factor. Let's copy this one, name this as velocity, and change this to a float. By default is 0.9, 0 and 1. So now we have this one. Now let's add the temperature here based on the noise, color ramp, and then add the noise. This is 100, and here this is 0.5 and this is 0.75, and also type here 0.9. Let me recheck that. Our temperature default is 1. I think is fine. Now let's delete this, add a icosphere to better see the effect of the melting. So we have this sphere. See, it is melting. Let's add the set smooth node. So we have shade smooth for this mesh. Okay, it's working. Now let's smooth the melted part of this mesh. So for that, let's add another store node here. Change this to Boolean, and this is mask. So we're going to update on this mask based on the velocity. Means the points that has a non-zero velocity going to have a true value for the mask. Let's duplicate this and add this here after the simulation input node. Now we have this velocity. Let's add the length node, vector length node, and when the magnitude of this velocity is greater than 0, this mask has a true value. So we have this, and next after the simulation output node, we're going to smooth the position of the vertices with the new node that is recently added to the geometry nodes is the blur node. Let's add the blur node and then add the position. So we are blurring the position of the vertices. So it is blurring a whole mesh, but we want to blur only the melted part. So for that we're going to use the mask attribute. See, this is default and this is two-step with the blur node. So we have this smooth mesh, and on top of that we can add the subdivision modifier to further smooth the surface. See, okay. And next let's add the mask based on the velocity and temperature, and that we will use in the material to add a different color to the melted and non-melted part of the mesh. So let's add the statistic attribute node, and then add the length, a vector length node, and then we're going to add the named attribute node and type here the velocity. So basically we are creating the mask based on the magnitude of the velocity and then mapping that magnitude between 0 and 1. Now let's store node and connect this to this and type here velocity mask, and let me rearrange this one. Let's duplicate this setup and connect this to this and this to the output. Delete this one, type here temperature and connect this to this and this to the value, and let's also rename this as temperature mask. So let me go outside this and let's add the named attribute. Let me type here velocity mask. So this is the velocity mask, and if we add the blur node we can smooth that mask. Change this to a float. Let's move this down, so let's blur by 3 times and also blur the temperature mask, so that will remove the sharp transitions between the velocity mask. See, we have this smooth velocity mask. Now let's add the material for this, then we will add the self collision. Set material node, and we have this material. Let's add that here and then go to the shading. Let's add the attribute node, type here velocity mask. You can also use the temperature mask. Then add the ramp node and plug this to the color. So we have the color based on the velocity. Let's make this gray and this is orange, something like this, and we can duplicate this, and with this mask we can also control the roughness and the bump map, and also make this metallic. And let's flip this. See, we have a nice transition for the color based on the velocity. So now let's add the collision mechanism to this setup. So before adding the self collision, let me explain the concept. And for the self collision, we're going to use the raycast node. So we are going to use the same target geometry as well as the source position. So in this way, if we directly shoot the ray from the vertex position, it doesn't work because ray is hitting its source position. So to overcome this problem, we're going to offset those vertices along the normal direction and then shoot the ray. So if the rays hit the other part of the mesh and satisfy a minimum distance criteria, then we're going to stop that point, means we're going to make the velocity of that point 0. So this is the idea behind this self collision. So let's first move this down and let's connect this as target geometry, and then we're going to offset the source position. Let's add the vector add node and then add the position, and next we need the scale, and then we're going to add the normal. So in this way we are offsetting the position along its normal, and this scale should be a very small value around 0.001. So in this way we are moving the positions along their normals, and the ray will not hit its source position, and the direction is the normal direction. Now we have this. Now we're going to add the AND node and also add the less than equal to node, means ray is hitting or not the mesh and it is satisfying the minimum distance criteria. Only then we're going to stop the velocity of the vertex. Ray length maybe 10 is enough. After that, let's add the switch node So we can means enable or disable this collision, and after that we need another switch node, and this is a float. So when the ray is not hitting, means we have false 1, otherwise 0. So 0 means we are multiplying 0 to the velocity. Here we have the velocity, so we're going to multiply this before the dam factor, and then plug this into this second socket. Put this in a frame, and this is self collision based on normals. And let's also output on this one. Let's output the switch node, and this is 0.05 minimum distance. This is self normal collisions, and this is min distance, and the default is 0.05 minimum. It can be 001, and maximum it can be anything. Okay, so we have this, and let me check this again. Because we are checking this along the normal of this mesh, this collision mechanism work well when we want to inflate this object. Add here a normal, so we are making the forced direction along the normal of this mesh. Let me first do this without the self collisions. There is no collision here. Let me change the mesh to a monkey, so that is more a complex mesh. Let me for the moment disable the subdivisions. The mesh is overlapping itself, so if we enable this self collisions, see, it is try to avoid this. So we can also smooth on this mask, this collision mask, to get this nice effect during this collision. So let's add the blur node here. Let me connect this to this. Here 2 iteration is fine. Now let's go outside and check this. See, this white part is where the velocity is 0. Or we can see where the mesh will glide, so it making the velocity 0 there. And it works better if you have a more dense mesh, then it has some more points to check for the collisions. Okay, now let's add the self collision based on the velocity. So for that, let me duplicate this one here, and we need the velocity. So this is the velocity, resultant velocity, and we're going to normalize this and then connect this instead of this normal. So delete this one. So this is the self collision based on the velocity, and then we're going to add the OR operation here, and then plug this into the switch node. Let me also move this and this outside this frame. Okay, and let's also separate on the settings for this. So this is the switch for this, and this is the minimum distance. So for this, I think minimum distance by default is 0.35, and for this, let me rename this as velocity and min distance, and this is 0.5. Okay, and we can also add this as output to smooth the collision smooth iterations. And further we can add a partition for this. So this is our collision section here, and after that we can also output this smooth vectors for the mesh, then for the velocity and for the temperature. So here we have set up the velocity and temperature. Then we check here for the mask to smooth the mesh, and here we have set up the collision mechanism based on the velocity and based on the normals. And this is the smooth operations for the mesh, velocity and temperature mask. So now let's check this self collision based on the velocity. Let me also add a downward force to this, so we have a proper effect to see for the self collision of velocity. See, it is not intersecting itself. We can also check for the icosphere. So this is it about this setup. Now I'll show you the preset that you can download from the Blender Market or from my Patreon page. So this is the preset and it has two more collision options. One is based on the proximity and another is based on the external mesh. And it also has a start or end frame settings, and you can download this from the Blender Market or from my Patreon page. So if you like this work, then please do support me and subscribe to my channel for more updates. Until next time, happy noding. Bye.